Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be demonstrating some of our options in 2009 and also some tips and tricks that we have throughout the program. One of the improvements we've made in 2009 is choosing our geometries when we have a face with an outside geometry, an outside chain, as well as many inside chains. So what we've done to make this easier to be chosen, because sometimes I'd like to choose only the outside or only the inside, or sometimes even both, I'll simply go to define, and if I go to multi-chain, we have the option of faces. Now when I choose the option of faces, we have here the option of choosing either external loops or internal loops, or both. If I have to choose to work with only external loops, when I touch the surface, I will only get the outside chain. It will ignore everything that's inside that boundary itself. Doing unselect will unselect that boundary. If I have to do select and choose to do internal loops instead of external loops, this time I'll get all of the internal loops without choosing the external loop, making it a lot easier to do individual pockets such as these without having to go back and erase the external chain that I have over here. Another one of the improvements that we've made within choosing our geometry is the gap control that we have on chain. If you remember correctly, if we needed to change the gap control of our chains, we would have to go in to our SolidCAM settings and simply go into our units and change the gap control over here. And every single time we need to do it within a specific geometry, we would always have to go back there to do it. What we've done now is very simple. If we take an operation, say profile operation, and we go to choose our geometry, we have our gap control within the place where we choose our geometry itself. In other words, I don't have to go back to our SolidCAM settings to change my gap control. So I can change it right here if I want to a gap minimum of, let's say, 0.1 instead of doing it back over there. Now when I do my add multi-chain and say choose, for example, this text over here, this is easily done now with the gap control and making these text without gaps at all within it. We've also made improvements in our face milling in choosing geometries. If I would go into my face milling operation and choose my geometry by using faces, let's say I choose these faces as shown over here, all around the part. Those are the faces I'd like to machine, or that I've chosen actually in this geometry. First of all, you'll note it'll do one boundary around all of them. I can separate them, but that's not new. What is new is the fact that we have now checkboxes over here. And I can simply say which ones I want and which ones I don't want to use. So let's say I don't want to use these particular chains shown over here. I simply take off the check mark on every single one of those chains, and only the ones that have the check marks will be used for this geometry. Now in this part that we see on our screen, I'd like to show some tips and tricks and how to use our geometry selection for slots such as this or this area over here, and also to show some of the ways of using an open pocket such as this pocket over here. We'll start off by showing you this area over here. If you'll note, this area, I'd like to actually machine it by simply going across this way onto this chain over here and continue on this way without going into these areas at all. This is simply done by choosing my operation of profile, and if I go into define, we choose the option in our chains of curve plus closed corners. By doing that, all I have to do is hit this first curve over here, and then when I hit my second curve over here, you'll note that the chain will automatically close itself at the corner, basically connecting those two chains together. Same thing with this side over here, and we've also closed this corner over here as well, thereby giving us a complete chain around that area to be machined out. Now, the next thing I'd like to show you on this part is milling out these two slotted areas over here. This area over here and this area over here. The way I'd like to do that is I'd like to have first the tool go down the middle of both of these areas over here and then work on each individual wall. So this would be done in two separate operations. However, I'd like to do this using the same geometry for both operations. We'll start by creating our geometry, and we'll choose this as our first chain, and we'll accept that. This one as my second chain, and simply change the direction of that. My third chain, and my last chain over there. The tool that I will be using will be a 12mm end mill. My levels, my profile depth will be up until that floor over there. And now we'll go into our technology area. Now if we go into our modify geometry area, first of all I want to choose to work on the center. Now when I click on geometry, you'll see my tool is actually going on the center of the toolpath. Now I'd actually like to move that over to be in between these tool paths. So when I go into modify offset, we have the option here of take half of selected offset. If I click now on this line over here, I'll get the automatic halfway point between that offset over there, going exactly in between those two chains. Now I'll also do the following. I'll also click on apply to all. So this will apply now to every single one of those geometries. Now you'll note the second and third chain I don't need. So I'll simply remove the V marks from those chains. Now I'll continue by doing a finish cut on this part because I only want to go down the middle. And in my link area, I'll simply have a lead in using tangent of say 10mm, and the same for my lead out. If we do save and calculate and take a look at our tool path, you'll see that the tool will go down. The tool will go down right through the middle, go over to the next air side, and go through the middle of that side, and then we're done. Now for my next operation where I want to go exactly on the walls itself, all I'll do is simply do a quick save and copy, go back into my technology field, choose left, and in my geometry area, I'll re-choose these two chains over here and change the offset value to 0, change its value back to 0 for all my offsets, so it can work now on the walls itself. And if we do now save and calculate and simulate this, you'll see that the tool will now work exactly on each one of those walls, finishing that wall exactly the way it should be. So within one geometry, I was able to do two separate operations, and using part of the chains in one geometry and all of the chains in the other operation. Now, one other thing I'd like to show here is how we work on this open pocket over here. You'll note that when we create a geometry, we'll have to create a geometry around this area, but mark this area as an open pocket. So I'll start my pocket operation, and when I go to geometry, I'll choose my chain geometry starting from, say, over here and going around automatically around the part itself. Now, I still have to mark these edges here as open pockets. This is simply done by right-clicking on the chain itself, and we have the option here called Mark Open Edges. Now, what I'll do is I'll choose the option of From and To Entities, and I'll say this is the beginning entity where I want to start my open pocket, and that's the end entity where I want to end my open pocket. And you'll see it's automatically now marked in a black line. If I continue now, I'll choose a tool of 10mm. My levels, my depth will be to that step over there. And in my technology area, we now have this field that's open called Open Pocket. Now, in the open pocket, we have the option of how much do I want the tool to extend past that boundary itself. And I can also use something called Use profile strategy. When I use the profile strategy, it'll actually work in here as if this was a profile with a clear step over. If we take a look at our simulation after I calculate the part, you'll see, and I'll use the top view for this, showing my toolpath. The tool will go in, clear this area exactly as if it was a profile with a clear step over. We've also made some changes in controlling our tool data. Let's say, for example, we have here tool number 1. We have here the option of change tool data. You'll see all of the tools, all of the operations using that particular tool in that group, and I can show every single one of those operations later on that are also using that particular. If I want to change the tool data in every single one of those, simply do exactly as you see on my screen now, with all of them being marked, and change the value as needed. For instance, I can change my value here to 2000 and my feed to, say, 200. When I say OK, every single one of these operations were changed. For example, if I were to go into the data of my first operation in that tool, you'll see that we have now the new value of 2,200. The same is true with my second operation as well. Go in here, look at the tool data, and you'll see that also has been changed. Now, there are times where I'd like to change the tool data, but not in every single one of the operations. So I'll simply go back into Change Tool Data and only mark the operations where I wanted to have changed. For instance, let's say I only want to have it changed in my first operation, and I'll put this at 1,500 and this at 100. If I go into my first operation, you'll see that it was changed in this operation. But if I were to go now into my second operation, you'll see that the tool data stayed exactly the way it was before. Now, in addition, we've also made some changes in our feed lead in and lead out. We actually added now a field which allows us to control the lead in feed and the lead out feed by percentage. I can have the feed lead in drop by a certain percentage and the feed lead out go up by a certain percentage. I have complete control of this field. In addition, we've also added a new option for tool coolant. If I were to click on the button over here called tool coolant, you'll see that we have a number of different options for tool coolant. Now, where we have a star on the side of that particular type of coolant, that is what is supported by this particular type of controller. So if I want to have a flood coolant on this operation or this tool, simply check flood. If I want to have through the tool pressure or air blast or whatever is available for this particular tool, choose exactly what is needed. Next, we'll take a quick look at our new drill sorting options. If we were to open up an operation over here, say drilling, and we'll choose our geometry as these holes over here. I'll go and choose my tool, say a 6mm spot drill, my levels according to this particular diameter over here. When I go into my technology area, we have here this sort sequence by default. By default means the exact same way the part was built. However, we have here a new option called Advanced. By Advanced, I can simply go into the field and choose what's the exact way I want to have my drills sorted out. For example, if I want to drill from the top to the bottom in this fashion, simply choose that option. And if I go into Show Sorted, you'll see that my tools are sorted out exactly in that pattern. Choose a different pattern, such as this one over here. You'll see that is now changed automatically according to that pattern. Basically, I can do any single pattern I want for this operation. Now, let's make a little bit of a change here. I'm going to change my geometry, and instead of choosing what I have over here, I'll choose these holes over here. Now, you can see that it looks a little messy the way it wants to be drilled. And I'm also drilling out the center, which I don't need. So as far as the center goes, all I have to do over there is simply choose the option of unselect, and I'll touch that over there, getting rid of that hole that does not have to be drilled out. Now, when I go into my technology area and choose sequence, I can use now the option called circular instead of linear. First, I'll choose my sort center. My sort center I'll choose as that circle over there. And now I'll just simply choose the pattern I want to use. If I want to use this pattern over here, simply click on it, and you'll see it'll automatically go according to that pattern. If I want to have a different pattern, say this one over here, I'll simply choose that pattern, and now it'll go according to that pattern, whichever is more feasible for my needs. We've also added a sorting option in our regular chains as well. If we were to go into this operation, for example, we have here in our technology area a field called Advanced Sort. Now let's first take a look at the simulation before I use the Advanced Sort. You'll note that my pockets are going to be milled out from one area and then jump to a different area, being done randomly according to the way the part itself was built, the way the chains were chosen. This is not always necessarily the most efficient way to mill this out. You'd rather have it going in a specific area of one to the next. So in the advanced area, we can simply choose Advanced Sort and choose the pattern I'd like. For example, if I want this pattern over here and then run my simulation, you'll see that the tool will work starting here and going up to the next one and then going across, making it for a more efficient tool path on the part itself. Now we've also made some changes in our ramping option within the pocket. If I were to open this pocket operation over here, we have the ramping of helical. Now let's just take a quick look of our simulation, and you'll see that the ramping goes in at a specific area, exactly at that point over there, and then spreads out through the rest of the part. Now, if I want to change the entry point, instead of being to where it is right now, all I have to do right now is simply go into my data of my helical and pick a different point. I can pick, for example, this point over here, and in my second chain have it at this point over here, and accept that. Now if we take a look at our simulation, you'll see that the entry point is now from this area over here instead of from where it was before. Let's take a look at it from our isometric view. You'll see again that it has changed now from this area to this area over here, and the same thing on the other side. We now have complete control of our entry point in our pocket operations. Now we've also added in our profile operation an option called Complete Z Level. If we take a look at this part, you'll note that we have here thin walls, and I want to mill out every single one of these slots here. Now, if I were to mill this all down in one shot each time and then go on to the next one, we run the risk of actually bending these walls. So what we've done here is as follows. Let's first take a look at the simulation, what we have right now. As you can see, the tool will go down and complete each area, but this is not necessarily good for the walls, as I've said before. So what we've done now in our technology area is we've added the option called Complete Z Level. What this will do is as follows. If we take a look at the simulation, the tool will go down and then move over to the next slot, working only on that Z level. When it finishes that Z level, it'll go back to the beginning and start the slot again at the next Z level, and slowly but surely then completing every single level, avoiding the risk of bending these walls. Now in this part, we'd like to show some of the improvements that we've added for clear offset on the part. What we would like to do is mill out these steps with a 10 millimeter end mill, but the length of this area itself is 40 millimeters. So what we'll do is we'll be using the option of clear offset to step in on that step itself. If I open my operation, you'll see that my geometry are those areas over there, those 4 edges. My tool is a 10 millimeter end mill. My level is down to the bottom step. And in my technology area, we've used the option here of clear offset, where our offset is 35 millimeters out and stepping over every 5 millimeters. Soon we'll pay attention to how we can use complete Z-level and sort by chains. But first let's take a look at our simulation. If we take a look at the simulation, you'll see that the tool goes down and mills out every single step until the bottom level, and then goes to the next step in till the bottom, and does the same for every one of these steps on the side. Now what I'd like to do is I'd like to have it clear all the way across and then go down to the next step. So for that we use the option of complete Z-level. Let's take a quick look at the simulation this time, and you'll see this time the tool goes down and finishes the Z-level and then goes over to the next step and does the same thing there. When it finishes all of the steps, then it goes back to the beginning and does the same thing on each level. But now I'd like to do one more thing. I'd like to use the option of sort by chains. Sort by chains will allow the tool to finish that entire step and only then go over to the next step. If we take a look at our simulation, you'll see this time the tool goes down, clears that step on that Z level, and stays on that step going down to the next Z level. When it finishes this step, then it will go over to the next step over here, and then finishing this step, and the same thing with the rest of the steps on this part. Now we've also made some improvements on our face milling technology. If we go into our operation for a moment, you'll see that my geometry includes that entire top area, and I'll be using a 40 millimeter face mill. My levels, I have to take 5 millimeters off from the top to get to my depth. And in my technology area, I'll be using hatch. Now my tool overlap will be at 30%, and we've added also the option of zigzag and one way. Let's just take a look at one way. If we take a look at our simulation, what actually happens is that the tool goes down, then it finishes off the toolpath, goes back up, goes to the beginning, and then continues the toolpath again. If I were to change this to zigzag, then the toolpath in this particular case will go down, across, finish, and then go down at this point and work its way back without going up every single time to the very beginning. Now, let's take a top view. We hope you've enjoyed our demonstration. You'll note some of the options in SolidCamp 2009. My first toolpath, my second toolpath, my third toolpath, and have a nice very little material left for the last tool. We had a small step over here. So we've added an option here called equal step over. What that does, it turns this into a minimum overlap. By doing that, we'll get a more equal step over as we go along the part. If we take a look as we go along, you'll see the toolpath goes down, across, and it's a little smaller now over here, but you'll see now that the toolpath are now equally divided along the part itself. In addition, we've also added the option of reverse if we want to go in the reverse direction. In this last part, I'd like to show some of the improvements we've made in Contour 3D. I'll start my operation of Contour 3D. My geometry in this particular case will be this area over here, this curve over here. And what I'd like to do there is actually put a chamfer on that edge. So I'll use a tool, a chamfer tool of 4 millimeters. And in my technology area, you'll note that we have here center. Center will actually allow it to go directly, the center being on that particular geometry. But in this particular case, I'd like to go on the left hand side of the geometry. Once I do that, these fields over here open, and I'll use the finish option using the option now of chamfer. This has now been added in. If I go into my chamfer area, I'll simply say my cutting diameter of the tool will use 1 millimeter of my cutting diameter. And if we go back to my levels area, you'll see we have a delta depth. I'll simply put in a delta depth of, say, minus 0.3 millimeters. Save and calculate. And if we take a look now at the simulation, you'll see that the tool will go down and work exactly on that edge, giving the exact chamfer following the 3D contour of the part itself.